As I'm working through your assignments, I've noticed that a lot of you are having some difficulty describing end behaviors in polynomial and exponential functions. So I thought I would work through a few examples to illustrate a little bit better how to describe these things. So we're going to start off here. We have a quadratic, so we have a parabola that's opening downwards. The vertex is at 0, positive 3. So when we're describing the behavior here, we're looking for something like as x approaches positive infinity, y approaches negative infinity. Wow, it's really difficult to make that. It's hard to see the negative there, but it is negative. So as x is getting bigger and bigger and bigger going towards the right, y is getting more and more negative as you go down. So that's basically what we're doing. We're trying to describe as x is going to the right, what's happening to the y. Is it getting bigger or is it getting smaller? So then if I do the other side, so as x approaches negative infinity, y is also going to approach negative infinity. Now if we were to sort of state the domain, x is an element of the reals, there's no restrictions, but our range is going to be y is less than or equal to 3, because there's no values that are bigger. Alright, so let's look at our next example. So in this example we have a cubic. So when we look at this cubic, we're stating the end behavior as x approaches negative infinity, so I'm going the other side this time. Y is going to approach, so if I'm looking as x goes to the negative, y is getting larger, so that's why we are going to put positive infinity. As x approaches positive infinity, y is going to approach negative infinity. Now, if I ask you to identify minimums and maximums, because they're going in opposite directions, there are no minimums or maximums located here. These points that we have, the little peak here and the little valley here, those are called relative minimums or maximums. Overall, this function has no minimums or maximums, they're relative only. If you look at the equation, we can tell very quickly that the y-intercept is going to be y. So that's just some of the information that we have here. Alright, our next function is a quartic. So when we look at this quartic, we have there's 3 turning points. There are 1, 2, 3, 4 x-intercepts, which is the maximum we can have because the degree is 4. When we look at our end behavior now, as x is approaching negative infinity, y is approaching positive infinity. So as x is getting more and more negative, y is getting more and more positive. Then we'll have, as x approaches positive infinity, y is going to approach positive infinity as well. Since both y's are going to positive infinity, this tells us that there has to be a minimum value. So our minimum value is at y equals negative 11. Or at least that's what it looks like on the graph when I read it very, very quickly. We have a y-intercept at positive 1, which we could tell from the equation. So this is always going to be the y-intercept as long as it's expanded. And then we have 4 x-intercepts. 1, 2, 3, 4. Now the last example we're going to look at for this stuff is an exponential function. So when I look at the graph of this exponential function, I am aware that there's an asymptote. So if I look at this, the asymptote is at y equals negative 3. So down here, if I were to sort of, this is going to be challenging. It's hard to draw a straight line. So this here, this is the asymptote.
Would Emily Hicks please return to room 317? Emily Hicks.
So now when we describe end behavior, so as x approaches positive infinity, y is approaching positive infinity. So as x is getting bigger and bigger, 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 y is going up. So that's why we're going to write it like that. As x is getting more negative, so going towards negative infinity, y is approaching negative 3. So this is going to happen whenever we have an exponential function. The y is going to be approaching the horizontal asymptote that we're looking at. So this y equals negative 3, that's a horizontal asymptote. There are no minimums or maximums here, because this value keeps on getting closer and closer to negative 3 without actually reaching it. And then going to positive infinity, it keeps getting larger and larger and larger. Hopefully this helps you identify behaviors a little bit better. If you still have difficulty, please let me know and I can try another approach.